are going to think about the chapter Structure of Atom. What is an atom? Do you have any idea about atom? Do you know the definition of atom? Atom is the smallest form of a chemical substance that can exist. This definition of atom sometimes may not give you clear idea. Before that, let me introduce the concept matter. Matter, do you know matter? That's your previous knowledge, isn't it? Matter is the entire thing in the universe, or the entire thing in the universe can be made up of matter. Matter needs space to occupy and it has definite mass. Such a thing is called matter. This matter has 7 states of matter: solid state, liquid state, gaseous state, plasma, Bose-Einstein condensate, fermionic condensate, quark-gluon plasma. The 4 states of matter, that is solid, liquid, gas, plasma, that is very well known to you. But the other 3 states, Bose-Einstein condensate, fermionic condensate and quark-gluon plasma, that is not that much familiar to you, but should keep in your mind now. There are 7 states of matter.
In this chapter, we have to think about what is an atom. Atom is the smallest form of matter. Many philosophers and scientists gave their own ideas about atom. Among that, John Dalton's atomic concept is very popular. We can think about Dalton's atomic theory. John Dalton is the scientist who proposed first atomic theory. Thus, he is known as the proponent of atomic theory. Now, we can discuss the various postulates of Dalton's atomic theory. Here, the various postulates of Dalton's atomic theory. The first postulate is matter is made up of minute particles called atom. That is, matter is made up of extremely small particles called atoms. They are showing the indivisible nature of atom. Second postulate is atom cannot be divided during chemical reactions. Atoms can neither be created nor be destroyed. That much smaller this reaction. During a chemical reaction, we cannot make a new atom. Like that, we cannot destroy also. The third and fourth postulates of Dalton's atomic theory we can discuss together. The third postulate is atoms of the same elements are identical in properties, size and mass. And the fourth postulate is atoms of different elements differ in their properties and mass. Here we can take 2 atoms. That means 2 different elements, atoms, hydrogen and oxygen. Hydrogen and oxygen are atoms, but they are atoms of different elements. Thus, they differ in their size, mass and properties. That tells the fourth postulates of Dalton's atomic theory. But if we are taking the atom hydrogen only, hydrogen has lot of atoms. That all atoms of hydrogen will be identical in their size, shape and properties. Like that, oxygen is another atom. Oxygen also have lot of atoms. All the atoms of oxygen are same in its size, mass and properties. If we are taking any other atom like sodium or potassium, they also have lot of atoms. The sodium element, it has lot of atoms, but all those atoms are identical in their mass, size and properties. But if we are taking the 3 atoms of different elements, just like sodium, hydrogen and oxygen, these 3 are atoms. Now we are taking 1 atom of hydrogen, 1 atom of sodium and 1 atom of oxygen. These 3 atoms are atoms of different elements. Thus, they are different in their size, mass and properties. This is telling the fourth and third postulates of Dalton's atomic theory. Next postulate of atomic theory is atom is the smallest particle that can take part in chemical reaction. From the definition or from the postulate itself, it is very clear. Since it is very small, or atom cannot be divided into smaller ones, it is the smallest particle that can take part in a chemical reaction. The last postulates of Dalton's atomic theory. Compounds are formed when atoms of two or more elements combine in a small whole number ratio that we can explain by taking the common example, common compound water. You all know the chemical formula of water. Water is H2O. From the chemical formula, it is very clear. Two hydrogen atom combines with one oxygen atom to form a molecule of water. There lies the simplest whole number ratio of water here. That is 2 hydrogen and 1 oxygen. Hydrogen and oxygen combine in 2:1 ratio to form always this water molecule. If it is forming 2:3, water will not form. It will be another compound, or there may not have an existence such a compound. Like that, if you are taking another compound, carbon dioxide. Carbon dioxide's chemical formula you all know, CO2. From the carbon 1, oxygen 2. The simple whole number ratio of carbon dioxide is 1:2. Another molecule or compound, if you are taking ammonia, NH3, 1 nitrogen, 3 hydrogen. Then the simple whole number ratio is 1:3. This explains the last postulates of Dalton's atomic theory. Hope the ideas of Dalton's atomic theory is very clear to you all. Followed by John Dalton, many scientists studied about the atom. Among these, the contributions of Sir Humphrey Davy, Michael Faraday, William Crookes, Julius Plucker, Goldstein, Roentgen, J.J. Thomson, Ernest Rutherford, James Chadwick, etc. are highly remarkable. The discovery of canal rays, cathode rays and anode rays lead to the concept of subatomic particles. Subatomic particles are particles inside atom. These scientists proved there are certain subatomic particles and thus atom is divisible. J.J. Thomson, through his experiment, proved the existence of negatively charged particle inside atom, and later it is known as electron. Thus, J.J. Thomson found the subatomic particle electron. Another scientist, Ernest Rutherford, through his gold foil experiment, proved the existence of positively charged particle inside atom. This positively charged particle is called protons. The subatomic particle proton is found by Rutherford. Atom as a whole electrically neutral. Thus, the number of protons and electrons in an atom will be same to maintain the electrical neutrality. After some years, the scientist James Chadwick proved the existence of another subatomic particle called neutron, which has considerable mass. This neutron is found by James Chadwick. Later, it is found there are hundreds of subatomic particles inside atom, but among these hundreds of subatomic particles, these three, that is proton, electron and neutron, are very important, and thus the fundamental particles of atom are proton, electron and neutron. Just see the properties of proton, electron and neutron. Now, from the indivisible concept of atom, we reached the existence of subatomic particles. Then there arose a question: if atom is divisible and there are particles inside it, how will be its structure? J.J. Thomson was the first scientist who came forward with a structure of atom. His model is called watermelon model or raisin pudding model. According to him, atom is spherical and all the positively charged protons spread inside and the negatively charged electrons are embedded in it. He compared this model to watermelon. The red fluffy parts of watermelon is compared to protons and the seeds embedded in it is to electrons. Or it is just like the raisin or nuts in pudding. Thus, his atom model is called watermelon model or raisin pudding model. There are a lot of drawbacks or demerits to this concept. Only the electrical neutrality of atom could be explained by this model. But J.J. Thomson's model is popular since it is the first attempt regarding the structure of atom. Then the scientist Ernest Rutherford came with the planetary model of atom. Through his gold foil experiment or alpha scattering experiment, Rutherford found all the positively charged particles of an atom are concentrated to the center and it is called the nucleus of atom. The negatively charged electrons are revolving around the nucleus in various shells or orbits. He compared his model with the solar system's planetary model. Sun is the center and planets are revolving around the sun. Just like that, around the positively charged nucleus, negatively charged electrons are revolving in various shells or orbits. Now, just see the various postulates of Rutherford's model once again. But Rutherford model also has lot of demerits. If a charged body is revolving around a circular path, it will radiate energy and finally there is chance to collapse with the nucleus. But in the case of atom, electrons are not hitting the atom. Rutherford could not explain this and that became the failure of this model. To explain the drawbacks of Rutherford's atom model, the scientist Niels Bohr gave some corrections in Rutherford's postulates. According to him, electrons are revolving around the nucleus in specific energy levels and he named these energy levels as n is equal to 1, 2, 3, etc. or KLMN, etc. Just see the various postulates of Niels Bohr's atom model. Electrons revolve around the nucleus of an atom in fixed paths called orbits or shells. Electrons in each shell have a definite energy, hence shells are also called energy levels. As long as an electron revolves in a particular orbit, its energy remains constant. The energy of the shells increases as the distance from the nucleus increases. The shells around the nucleus can be numbered from near the nucleus as 1, 2, 3, 4, 5, etc. or represented by the letters KLMNO, etc. These are the various postulates of Bohr's atom model. Thus, the three structures of atom, J.J. Thomson's, Rutherford and Niels Bohr are well explained here. അപ്പോൾ ഇന്നത്തെ ക്ലാസ് നിങ്ങൾക്ക് ഇഷ്ടമായെന്ന് കരുതുന്നു. സ്ട്രക്ചർ ഓഫ് ആറ്റം നിങ്ങൾക്ക് കൺസെപ്റ്റ് ക്ലിയർ ആയെന്ന് കരുതുന്നു. എല്ലാവരും വ്യൂ ചെയ്യുക, ലൈക്ക്, ഷെയർ ആൻഡ് സബ്സ്ക്രൈബ്. നിങ്ങളുടെ ഡൗട്ടുകൾ നിങ്ങൾക്ക് കമൻറ്റ് ബോക്സിൽ ഇടാവുന്നതാണ്. ഞാനത് കണ്ടതിന് ശേഷം നിങ്ങൾക്ക് വ്യക്തമായ മറുപടി തരുന്നതാണ്.